The best way for us to get a handle on the idea of variable amplitude and variable midline is to think through a couple examples. So here's one. The number of tourists visiting a resort averages 4,000 people annually and oscillates seasonally 1,000 above and below the average. The number of tourists increased by 200 per year. Create a model for the number of tourists starting from the peak season after T years. So we're going to do this, not this problem first, but we're just going to think a little bit about what's happening. So here is a graph of the number of tourists that are in this area, in this resort. Now, if we ignore the part about increasing by 200 per year and just sort of think about the behavior that we have, here's our average at 4,000, and it's going to go from above 5,000 to below 3,000, and it's going to have this oscillating behavior. It's going to go down in the next peak season, and then the quiet season, and then peak season, and so on. And so every year, we have this 1 year cycle, and then another year, we have another cycle. Right, so this is the picture without the increasing tourism. What does it mean then if we say we have increasing tourism? We're going to have a similar picture, except now, instead of having a flat average, that average is going to be increasing. We're still going to have this behavior of starting above, ending up below, and then above again after 1 year. But now there's another motion to take into consideration, which is that we've got this increasing midline. And so our problem is to create a model that takes into account all of this information. So let's take a look at this. I'm going to make an equation down here. Y equals, I'm going to write out the generic one first. A times either a sine or a cosine, we've got to figure out, times some quantity in terms of t plus d. In this case, I'm going to set the midline to 0 just to make life easy on us. And that's where also we have to figure out which function we're talking about. So we're talking about starting from the peak season, which is starting from above here. And that's going to be a cosine function. And so once we set that the beginning is here, then our horizontal shift c is equal to 0, and we can start from this point. And so we just have to get these values. The amplitude in this problem, the amount that we're going above and below the average, even in this situation, is going to be 1,000. So this is going to be 1,000 cosine of bt plus d. Okay, well, what is b? Well, remember that b is the value that corresponds to the period. The period is going to be 1 year, and b is 2 pi over the period, so b is 2 pi over 1, so 2 pi t. And so now the tricky part is this, the d. 4,000 people annually at the beginning and increases by 200 per year. So increasing by 200 per year. So at year 1, this midline right here is going to be 4,200, whereas it started off here at 4,000. Right? So how do we get an equation of a line that increases by 200 per year? Well, you can think of this as as slope-intercept form. We have the intercept, we know the slope is 200 per year. So this will be 4,000 plus the slope is increased by 200 per year, 200t. I'm going to put parentheses around this, although it's not strictly necessary. And the reason why is to emphasize that this right here represents the midline. And if you're not sure, you can always check this by thinking about a couple values. After 1 year, there should be 4,200, and you plug in t is equal to 1, you get that. After 2 years, it increases by another 200, so that's 4,400. Set t equal to 2, and you get 4,400. And so this right here is the model. Now you'll notice that a lot of this relies on your ability to create the basic models with constant amplitude and constant midline. But now that we're sort of stretching these things, most of this stays intact, and we just have this additional feature where we're saying, okay, well, what if the midline is changing? What changes? Well, the part that changes is just the midline portion. Here is another example. A population of fish oscillates 50 above and below the average during the year. The average starts at 800 fish and increases by 3% each month. Model the population in terms of months since January, assuming that the population is at its lowest in that month. Okay, so once again, we're going to try to break this apart. Now, there is something different in this one compared to the previous one, which is that our rate of increase is actually going to be a percentage rather than a fixed quantity. And so we're going to have to think about that part. But to begin with, what we want to do is we want to think about what's happening without the change of midline. This will help wrap our mind around what's going on. So we're starting at the low. So we have some midline here. In this case, we're starting at 800. It starts at its low, which is 50 below, which was 750. And it's going to go above and below. And this cycle repeats after 1 year. The peak is going to be 50 above, which is 850. Now the thing to pay attention to is that the time is measured in months. So I'm not going to put a 1 here for where it repeats. I'm going to put a 12 here because 12 months later is when it repeats. And this is going to impact when we calculate the period, the values that we're going to be using. Right, so here's our function, and we can immediately see this is going to be another negative cosine because it's starting at low, going to high, going to low. And so we could actually start writing some of this in. It's going to be negative 50 cosine of something, something, something plus something, right? So this is our BT term. And so we have to figure out B. Remember, B is 2 pi over the period. So B equals 2 pi over the period. The period is 12 months, so 2 pi over 12, which is pi over 6. So pi over 6t. Right, so this is the part that ignores the changing midline, just sets up our oscillation. And so now let's take a look at the midline. So for the midline, we're increasing by 3% per month. What does that mean? Well, at the beginning, we'll have 800. That's the starting point. And then it'll be 3% more than that. So it's going to be 800 plus 3% of 800. And if you look at that, that ends up being 1.03 times 800. Just write 3% as a decimal, 0.03, and then factor out the 800. This is what you get. Well, what happens another month later? What is that going to look like? Well, the math of this gets a little bit messy. This is actually something that you did back in Precalculus with exponential growth. But basically, we're going to have this quantity, 800 plus 3% times 800, plus it's going to grow by 3% of this. So 3% times 800 plus 3% times 800. Now again, it looks a little messy, but you can see they both have this 800 plus 3% times 800 term. So we'll factor that out. And if we factor that out, we'll have a 1 plus 3%, or 1.03. And if you think about this quantity, well, we just calculated it, that's also 1.03. So we have 1.03 times 800 times 1.03, 1.03 squared times 800. And this is starting to show us what the pattern will be. Every month that goes by, you're going to multiply by another 1.03 because that represents the previous population plus 3% more. And so when we put this all together, move that plus sign over here because I didn't leave myself quite enough space. This is going to be 1.03 to the tth power times 800. And so the general pattern that we see, if it increases by 3% per month, that's 1.03, 1 plus the 3% for every month that happens. It's raised to the tth power because it's compounding with the previous values.